glycan and anti-MPER neutralizing antibodies, but not anti-V2 glycan site-specific antibodies, are strongly associated with higher neutralization, breadth, and potency.
Okay, good afternoon, everybody, and thank you for coming down. I'll give, I guess, a bit more of the general conclusion of the work, which is that the autoreactivity of anti-HIV neutralizing antibodies doesn't prevent broad antibody responses. And just by way of a very quick introduction, I just wanted to kind of set your mind at some of the kind of problems that come up when trying to design an antibody-based HIV vaccine. First of all, no vaccine is actually ever induced broadly neutralizing antibodies, although there's been some inroads into this problem that were published, I think, about last week. And then one of the ways around this, and one of the ways people have tried to look further, has been epitope modeling, and I'll talk a little bit more about exactly what I mean by that, but these approaches have actually never been used before to generate any licensed vaccine, so there's no roadmap of success to kind of use for inspiration to kind of think about how to make it actually work. And then the main technical point, there are many other points, but what I'm going to focus on is autoreactivity and polyreactivity, and I'll define these terms a little bit later in the talk. But they're common among anti-HIV neutralizing antibodies, and they're thought to pose barriers to the development of neutralization breadth, which, as many of you know, actually seems to be the major problem with getting broadly neutralizing antibodies out of a vaccine, is that there would have to be multiple steps, so it looks. So, and so there are many, there we go. So there are many targets for broadly neutralizing antibodies. They've all been defined by monoclonal antibodies isolated from HIV-infected individuals. And this schematic is actually not quite up to date. There's actually one more site that doesn't appear on this map, but for our purposes, it'll suffice. And this approach of taking the most broadly neutralizing antibodies and working out what they recognize has been very fruitful, but it leaves a little bit of a gap. So if you kind of take the universe of antibodies, you take the broadest ones and then use that to work out kind of who these epitopes are. But what that doesn't tell you is what happens through all the rest of the people that don't make quite those broadly neutralizing antibodies. And that population of people is probably more a closer approximation of a population one might like to vaccinate. So we wanted to explore that a bit further. So what determines how you get to a broad antibody? Well, first, the individual would have to make a response to that epitope, and then that epitope would have to mature, and there's been quite a bit of recent literature about that. I'm going to hold back and not talk so much about number one, because one component of it is based on things like the immune dynamics within an individual and immunodominance. And although that's not the only thing going on, it is one part of what's going on. I'm going to focus more on how an antibody response needs to mature. So antibody genes have to mutate. These mutations have to lead it on a path to greater neutralization breadth. And there seem to be some very vast differences in the rates and the likelihood of doing that in the two cases that have been picked apart in the recent literature. And so when I think about it, if you think of greater neutralization breadth for antibodies targeting one or another epitope, should reflect some combination of these three items here. And together that they will mostly reflect the difficulty in achieving neutralization breadth for antibodies directed against that site in a human population. And that's what we wanted to get at. So we used three epitope targets. The first is what's called in this diagram the V2 glycans, but I'll call them the V2 glycan site because most of the epitope is actually protein. And then a combination of two epitopes because the mapping mutants overlap for them and the epitopes overlap. I'll call the V3 glycans collectively, even though the other glycans play a role, and that would include mostly, we'll capture with our mutants, most of the 2G12-like antibodies. And the third epitope we look at is near the membrane, and it's the only broadly neutralizing epitope on GP41, and it's the membrane proximal external region, or MPER. So just a quick little bit about autoreactivity. And I think this is actually very well described and very well displayed by some data from a paper recently published from Garnett-Kelso's group at Duke. And what they did is they had arrays of human proteins and put out on a slide, and you could sort of measure the antibody binding or anything binding, in this case antibody binding to this array of proteins. So on the x-axis here it'll be the broadly neutralizing antibody, and on the y-axis it'll be a control myeloma protein. And they had some controls for equity of antibody binding and some scanning controls that appear down here. And what you can actually see, if you look carefully, if we start with the anti-MPER antibodies, is that a couple of them, they actually identified an autoantigen and then did some work to verify them. And in addition, you have this phenomena which appears a lot in autoimmunity that it's called polyreactivity, where you see a lot of binding activity, or very little binding activity, but increased to a reasonably large array of proteins or epitope surfaces. And that shows up here and also down here. And you sort of get a good idea of it, where you can see that the broadly neutralizing antibody binds slightly better to a lot of these compared to the myeloma control, and sort of gives you a bit of a bulge in the graph. And what this, although it's been, this autoreactivity, polyreactivity has been described in the literature for a decade for anti-MPER antibodies. To my knowledge, this is the first time it comes up with 2 or 3 anti-V3 glycan antibodies they tested showing up as polyreactive in this assay. So it's the anti-MPER and the anti-V3 glycan antibodies that show up quite frequently as either autoreactive or polyreactive. So in our study, what we did was we took a cohort of chronically infected individuals, we measured the neutralization breadth and potency, and then we compared it to mapping for when we could find antibodies to any or each of these 3 epitopes, and use that comparison to try to assess the likely contribution of antibodies to neutralization breadth and potency overall in the cohort. So very, very quickly here, we had 177 individuals infected more than a year, antiretroviral naive, except for prevention of mother-to-child transmission in Cape Town, and a relatively hard to neutralize and broad pseudovirus panel with 11 of the 24 viruses showing up as at least potentially more resistant than tier 2. So quickly for the mapping methods, for MPER mapping, we used a technique that was, and constructs that were developed in George Shaw's lab, where a HIV-1 MPER sequence is swapped into an HIV-2 envelope. And in order to try to capture as many specificities as possible, we used 3 different constructs with 3 different HIV-1 MPER sequences. For the V2 glycans and the V2 glycan-site and the V3 glycans, we mutated key residues in each epitope and looked for 3-fold drops in neutralization. And again, so you would compare neutralization of the parent virus to neutralization, say, of a mutant virus where one or another key amino acid in the epitope is mutated. And again, to try to capture as many specificities as possible, we used 3 parent viruses. So very, very quickly, to give you an idea just what the distribution of breadth and potency looked like, although I'm not going to show the data, for some of the analysis, we used a cutoff, which you can see here in red, with about partially arbitrary but intuitive, where about 1 in 6 sera showed up as either broad or potent. And this is the key point here. If we looked, we devised a method to try to estimate the error in measuring neutralization breadth and potency, so that you can get a sense of how, kind of what the range and what a confidence interval is on all of this. But if we compared MPER positive to negative samples, we found that the MPER positive samples on average neutralized 4.6 more viruses in the panel out of 24 than the MPER negative samples. You can see the distribution of negatives and positives over here for comparison. For the V3 glycan, positive versus negative, it was about 3¼ more viruses, more than the negatives on average. And again, here's the distribution, just so that you can kind of get an intuitive idea of how different it is. And surprisingly for us, when we found antibodies that neutralize the region where this V2 glycan site is, there was a negligible difference between the positives and negatives, and you can see there's actually no difference between the distributions. If we looked at potencies, the MPER positives were about 2-fold more potent than the MPER negative sera, and the V3 glycan site positive samples are about 1.7 times more potent than the V3 glycan negative sera. And realize here, since it's a mutational analysis, we're picking out only the ones where this is the dominant antibody to neutralize one of our 3 test mapping parent viruses. And with the V2 glycan site, there was actually no difference at all, looking by either method. So, as I've said, actually, I'll move quite along. So we're using some new approaches because the old approaches haven't worked, and there are some candidate immunogens that are defined by these targets. And antibodies to some of these targets are autoreactive or polyreactive, and that's thought to make it more difficult to make breadth. But it's these targets whose antibodies are associated with breadth when you look at what happens in people who are chronically infected. And I conclude from this that autoreactivity and polyreactivity may have an effect, but that effect isn't decisive, and that these targets should remain high priority vaccine candidates. Just for a moment, I'll make a bit of a plug. Looking for a postdoc, and although everybody's welcome, citizens of member states for ICGEB, which is an intergovernmental organization, appear in green on this slide, are all eligible to apply for internal fellowships, and anybody who's interested is encouraged to contact me. And we take the international part of the name at least a little bit seriously. And so I want to thank everybody who is or has been in my lab, highlighting the people who did the work here: Rajesh Jacob, Fatima Abrahams, Tendeka Moyo, and Berta Grau Pujol. Thank you very much. I'll take questions.
Questions? Well, I have a couple questions. So first of all, what about the 10E8 antibody? Did you try that in your initial experiment? It's against this.
You mean that experiment that's actually the Garnet Kelso, the protein array experiment?
Yeah, in the.
It's actually there in the slide.
Sorry.
Whoops.
No, not that one. The in your flow cytometry. Yeah, there we go.
There we go. In the things that look like flow. So that's 10E8 over there.
Oh, okay.
And they claim they have an autoantigen for 10E8.
So you are seeing some autoreactivity.
Well, they do. This isn't my work. This is Garnet Kelso's.
And I was wondering, what are you diluting your cells in?
For this experiment?
Yeah.
I'd have to look. This isn't my work. This was sort of by way of introduction.
Okay.
I'm sure they must block, but I'd have to go back and check. We talked about this yesterday, but I didn't get a chance to go back and check.
Oh, okay. Okay, that's very interesting. And also I wanted to know, with the MPER results that you got where you saw reactivity against MPER, have you tried putting in peptide to block the neutralization?
I don't think they tried to put peptide in, no.
Okay.
Not here, but yeah. I'll pull the paper out. We'll go over it.
Okay.
That'd be good. Yeah, like I say, this slide wasn't our work. It was the sera that came down here. So this all is ours. And the fact that when you actually look what people respond to and what seems to make breadth here, it seems to be much more antibodies against MPER and the V3 glycans than it is antibodies against the V2 glycan site.
Right? So
it's a correlation.
If you block the MPER reactivity, does the neutralization go away or anything?
Well, yes, actually, we have that. Oh, I don't have a slide for that, but we have that for a handful of the sera. I'm sorry, I misunderstood the question. Yeah, in this point here, we have for a handful of these sera where you go and block. We actually depleted. We put biotinylated peptide on beads, and you watch the neutralization go away.
Okay.
All right.
Thank you. Okay, so, oh. Ugh.